When air, non-condensable gases, or other vapors are trapped inside a heat exchanger, they can prevent the unit from operating efficiently. This is because the air or gas can either blanket the tubes or block the tubes off and prevent fluid from flowing through them. The effect is the same as the effect created by fouling. Less heat can be transferred across the tubes. Gas trapped on the tube side of a heat exchanger can block off tubes and prevent fluid from passing through them. Gas trapped on the shell side can displace the shell side fluid at the top of the heat exchanger. This can reduce the amount of tube surface area that is exposed to the shell side fluid, and thus reduce the amount of heat that can be transferred. There are many ways that air or other gases can get trapped inside a heat exchanger. For example, this can happen during the startup of the unit. During startup, the heat exchanger should be vented to remove unwanted gases. If the venting is not complete, gases will remain inside the unit. Another source of gases is the process itself. In some situations, the process can produce vapor bubbles. As the process fluid passes through the heat exchanger, the vapor collects inside the unit. When maintenance is performed on process equipment, air may be trapped in the piping or shell as the equipment is put back together. When the equipment is restarted, the air can make its way to the heat exchanger and become trapped inside. No matter how air or other gases get trapped inside a heat exchanger, they can cause it to become airbound or vapor-bound. There are several symptoms to indicate this. For example, when trapped gas blocks flow to some of the tubes, the outlet temperatures of the two fluids may change. This is because the gas is restricting flow into the tubes, and the restricted flow causes less heat transfer surface area to be available. The decrease in heat transfer surface area will cause the outlet temperature of the process fluid to increase, since less heat will be removed from the fluid. There are also situations where the pressure inside a heat exchanger may be affected. For example, this can occur in heat exchangers that are used to condense process vapors. In this situation, non-condensable gases partially fill the unit, reducing the amount of heat transfer area that the process vapor can come in contact with. In turn, this reduces the amount of vapor that can be condensed. The flow of vapor will start to decrease, and the pressure inside the unit will start to increase. Regardless of how gases get into the heat exchanger, the unit must be vented to allow them to escape. Repeated venting may be necessary to ensure that the heat exchanger remains free of air and other undesirable gases. However, excessive venting can cause its own problems. For example, each venting may allow a small amount of the process fluid to be lost from the process. This reduces the efficiency of the process. Venting may be only a temporary fix. If the source of the gas is the process, there may be a problem with the process or with one of the components in the process.